Welcome to another day on the Journey to Chem. Well, I'm excited today because we're starting a new subject. Well, today's warm-up is going to prepare us for that. So you need to review your decompositions and how to get a complete balanced equation. So do the best you can, and I'll see you in a moment. In number one, I am getting a complete balanced equation for my decompositions. Well, my very first decomposition is one of my most favorite, potassium chlorate. Potassium chlorate is a metallic chlorate. And whenever I decompose it, I always get some kind of a common molecule. In this case, I get oxygen. And what's left is potassium chloride. So first I get my products, and then I balance the atoms. Well, there are 3 oxygens here and 2 oxygens here, and the common multiple would be 6. Therefore, I need 3 of these oxygens and 2 of the potassium chlorates. Well, once I get 2 potassiums here, I must have 2 potassiums on the other side. For B, I have magnesium hydroxide. Well, magnesium hydroxide is a base. A metal with a hydroxide is a base. And when I heat up this base, I'm going to drive off the common molecule of water. And I'm left with a base anhydride. Now, you do remember that in order to write the formulas correctly, we must balance the charges. Magnesium is +2 and oxygen is -2. Potassium is +1 and chlorine is -1. We'll always be doing that. And the last one in number 1 is calcium carbonate. And the common molecule I get here is carbon dioxide. And I'm left with a base anhydride. Now, carbonate reminds me of carbonated beverages. I like those little bubbles, and that would be the carbon dioxide. Carbonated beverages are giving me the carbon dioxide. So maybe that'll help you remember. Now in number 2, we have a double displacement. I am given sodium iodide plus water. And I write water as HOH to show me that hydrogen separates and hydroxide becomes separate. And I do the do-si-do and change partners. And therefore we get hydroiodic acid and sodium hydroxide. Hydroic tells me there's no oxygen in this acid. Hydroiodic acid. And when I have a salt plus water, I get an acid and a base. So we can see this on a variety of different levels. Now to discuss the new material, I'll be right back. Now if you take a look at topic 8, Worksheet A, it gives you the process that I'm going to be using in order to do a mass problem. I'm starting with mass, and I'm going to end with mass. Now, I picked out my very favorite equation of decomposing potassium chlorate. And we did that in the 3rd lab of the last section on moles. And we started with 1.00 grams. And you'll remember, we did not want to touch that crucible because fingerprints add mass. Now, when I decompose this, I want to know what mass of oxygen will be given off. And we did it experimentally, but we could also do it calculated in this way. But we also calculated it based on the percent composition. Now in this, I take my 1.00 grams of potassium chlorate and I change my grams to something new and different, moles. We just love those moles. And 1 mole of potassium chlorate, this is just one big conversion factor. Well, I have to get the gram formula mass. Potassium has a mass of 39.1. Chlorine has a mass of 35.5. And I have 3 oxygens. And each oxygen has a mass of 16 AMU. Then I'm always put them again because I know that that is where the mistakes are made in the atomic masses and adding up that gram formula mass. I see that all the time, and you don't want to make that mistake, so you're going to be very thorough with how you get your gram formula mass. Now, when I add these up, I get 122.6 AMU. 122.6 grams of potassium chlorate is equal to 1 mole of potassium chlorate. Then comes the new part. In order to change from one compound to another, this is my recipe. I have to follow my recipe, and therefore I know there are 3 moles of oxygen for every 2 moles of potassium chlorate. I could be solving for an unknown anywhere in that equation, and the process would still be the same. It doesn't matter if it's a reactant or a product. All I need to know is where I'm starting and where I'm going. This, when I look at this, I see that my grams of potassium chlorate are canceling. And I always want to put what I need to cancel in the bottom and what I'm looking for in the top. And these moles will also cancel. And that gets me to the moles of the oxygen. And at this point, you can see why it's so important that we continually write the compound so that we always know what we're talking about. It'd be very difficult to go to the grocery store and try to buy something if I didn't know what I needed. So you need to know what you're talking about here. And once I get to moles, then I'm going to mass. And 1 mole of oxygen has a mass of 32.0 grams of oxygen. Now, when we do this in the calculator, let's do this together. Do you have your calculator there? All right. Well, 1 divided by 122.6 equals times 3 equals divided by 2 equals times 32 equals. Now, yes, I am also dividing by 1 and multiplying by 1, but I know that gives me the same number, so I don't need to go through that. It is, however, important to put the equals in between because our calculator has a standard order of operation and it will always multiply before it divides. And we need to make sure that it's doing what we want it to do and not have a mind of its own. Therefore, when I do this math, I am going to come out with 0.3915 grams. I go back to my original problem. I had 3 significant digits. Therefore, I need 3 significant digits in my answer. And my answer would be 39, and I take the 5 and I round it up, grams of potassium, of oxygen was what I was looking for. And that would be the answer to this problem. What you do is first you get your balanced equation. Then you change your grams to moles of your known. Then you use the mole ratio from the balanced equation to change from one compound to the one that you're looking for. And finally, you just change those moles back to grams. And that's not so hard. I know you can do it. And the first question on worksheet A, you need to get a complete balanced equation, and the problem only gives you one of the products. So make sure that you do the double displacement to get both of the products. I know you'll do well, and tomorrow we'll have some more practice. Well, that was some fun, and thank you for being here, and I can't wait to see you tomorrow.